Hi everyone, and welcome to Mike Likes Robots, where we share knowledge to accelerate robotics. This is video 14 of the Advent of Code series. Unfortunately, I already recorded a full hour video and I didn't record the screen capture. So that makes all of that footage a bit useless. So what I'm planning to do here is record a shorter video going over my thought process and issues that I ran into, and then finding the final result, because I managed to complete day 12 in the video. So first, I'm going to open up Paint and show my thought processes for finding the discounted fence around a region. So as a reminder, we're trying to take a group of letters that are in a 2D grid, and we're trying to find the fewest number of walls that will enclose that region. So for a single letter, it's 4 fences. And for, let's have slightly more interesting shape. Here it is 1, 2, 3, 4, 5, 6, 7, 8. So you have to join the consecutive walls together that are going along the same path. So my previous video, I got to this point and I was trying to figure out how to do it and got pretty stumped. Then I had a bit of a moment of inspiration. Instead of taking a point and working out the rest of the points, I started thinking about scanning from the top row to the bottom row. So here's the thinking. You can scan the top row or above the top row, and it's got nothing in. Then you want to scan the next row and find the differences. So we've got 2 new A's introduced. So we need to create walls for both of them, or fences for both of them. Then we scan the next row, and there are still some A's present, so we don't need to create fences for those, but we do have a new A here. So we need to create another wall, another fence. Then we go from our set of A's off to nothing. And at that point, we need a wall. And it's just one wall because it covers all 3 A's. So that's kind of the algorithm. What that ends up giving us is 1 wall, 2 wall, 3 walls, and 4 walls. So once we've scanned from top to bottom, we're then going to repeat the process from left to right. That'll give us an empty column. The first column, we have 2 new A's, so we put a wall there. This column, we've got 1 new A, so because it's continuing on, we don't put a wall. Because this goes on to empty space, we need a wall. Again, this is going from empty space to an A, so we need a wall. And then from here, it goes from 2 A's onto nothing, so we need 1 long wall. So it goes along, we create a wall, 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 and a wall. This gives us our final count. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that means that to create this algorithm, what we need to do is create a scanning function from top to bottom and a scanning function from left to right, where it checks the differences with the previous row. So let's say we have this shape. We have the columns 0, 1, and 2, and the rows 0 and 1. If we're scanning from top to bottom, then we're looking at the 0th row. So we'll have 0 and 2 in an array. So first we're comparing an empty array with 0 and 2, and we find there are 2 differences. Then we're comparing 0 and 2 with 0, 1, and 2. And the differences between these 2 arrays are this 1. So that means that we add 1 wall. And then finally, we're comparing this array again with an empty array. So that's -1, 0, 1, and 2. So that takes 0, 1, and 2 and gives us, at the moment, it gives us 3 walls, which is where the next part of our algorithm comes in, which is that we are grouping consecutive numbers together. So we need to say, because the difference between 0 and 1 is 1, we're going to get rid of that 1, And because the difference between 1 and 2 is 1, we're going to get rid of that 2. So that leaves us effectively crossing these out and saying 0. So between -1 and 0, we gain 2 walls. Between 0 and 1, we gain 1 wall. And between 1 and 2, we gain 1 wall. So that's the algorithm. It works the same top to bottom and left to right. And I prove that by using the same function to compute the differences. So with that explanation, I hope that makes sense. I'm going to switch to the code and show it working. So most of this is exactly the same. I refactor a little bit. So first there's a new function, perimeter with discount. Then there's a second new function, cost with discount, where part A uses the cost function and part B uses the cost with discount function. Now all I've done to refactor is take the contents of part A, move it into a separate function, and then I pass in the cost function that I want to use. So for part A, I just calc cost using cost function. For part B, I calc cost using cost with discount function, where I pass it in here. So that was fairly straightforward to implement. Perimeter is exactly the same. We don't need to change that. And the rest of it is just adding new unit tests to check that I get the right answer. So if I open this out, I can explain exactly what I did. So we are first scanning from top to bottom. I first create 2 closures. These could be separate functions, but this count distinct closure, basically what it does is this 0, 1, 2 array, it's going to count that this is one group. So it's one distinct group. And how it does it is by going along a vector, and it keeps a track of distinct values, and it keeps a track of the previous value. On the first iteration, it's none. On all the remaining iterations, it is some. That's why it's an option. So if there is a difference of of more than 1, and we use the absdiff function here, if there's a difference of more than 1 from the current value to the previous value, then it's a distinct value. So if we have the array 0 and 2, then 2 is 2 more than 0. So this will fire, we add 1 to the distinct values. However, if it's 1, then the absolute difference is 1. It's equal to 1, so we skip this if function, and we just go straight to here. And the idea is that by scanning along and only adding 1 to distinct values, when we make a jump of more than 1, we count how many there are. So that's this closure. The next closure is the extra fences closure. So this calculates for 2 rows, the 0th row and the first row, for example, exactly how many extra fences do we need. So we do this by taking one iteration where we keep the values from the current row that are not in the previous row. Then we do it again where we take the previous row and keep all the values that are not in the current row. So that's the diff part of the algorithm. We're saying this one is new. And then when we go from 1 to 2, 0, 1, and 2 are in this array, but are not in this array. So with those 2 vectors, we've got our 2 rows, and this works exactly the same for columns. I just didn't rename it. It could just be current and previous instead of current row, previous row. Once we've got those 2, we then count the distinct for the current and count the distinct for the previous, and then add them together, and that's the result of extra fences. Okay, so then we want to scan from top to bottom. So we're going to keep track of the row index, which I set initially to -1. At this point, we need to have sorted the points where the row index is the priority, and that's the default. So points.sort puts that in order of row and then column. So we copy the region, we sort so that the row is the most important thing. Then we're checking every single point within that vector. If the row index of that point is different from the previous row, then we've gotten onto a new row, and we need to calculate the diff between the 2 previous rows. So we do the extra fences call that I described up here. Then we need to do some setup. So previous row becomes the current row gets cleared, and then we want to save the new point. So at this point, if we've got the 2 points 0, 0 and 1, 0, for example, first previous row index is -1. Then we take this point. Unfortunately, there is a slight complication where, because we've sorted it and pop takes from the back of the array, we're actually first taking 1, 0. So let's be accurate and just say point is 1, 0. So the current row index of that is 1. 1 is not equal to -1. So we need to check the two rows. Currently, current row and previous row are both empty vectors. So those are compared against each other. There are no extra fences. Then we say previous row is current row gets cleared, and then we push the new column index that we've just gotten here to the current row. So that would be 0 in this case. And that's because we want this vector, right? We're looking at the 0th row and we want the 0th column of it. So we only need to store the column. We don't need to store the row. So we store the column. That's that .1. Then we set the previous row index to the current row index. So now previous row index is 1. Then we go through the while loop again. We pop off 0, 0. So now point is 0, 0. And we check, is it a different row index? It is. So then we need to calculate the extra fences. At this point, our current row is set to 1, 0, and our previous row is empty. So we get one new row, and then we do our switching over, and then this while loop ends. So what we need to do at this point is 2 new calculations. And this is where I got stuck for quite a bit of time in the video, because I only did the current row with an empty vector. But what you actually are left with at this point from our example here is that the previous row is it's 1, 0. The current row is 0, 0. So we need to do the diff from 1, 0 to 0, 0. So we get 1. Then we need to do the diff from 0, 0 to an empty array. So that gives us another 1. And that's the algorithm complete. Now, we also need to scan from left to right. And here we do essentially exactly the same thing. We have one extra step, which is that we sort by the column index instead of the row. So for here, I do a comparison of the row index and the column index. And we check if the column is greater, then the point is greater. If the column is less, then the point is less. And then we check the row. So if the column at this point is equal, then the row being greater means it's greater. The row being less, it means it's less. And if they're both equal, then you get equal as a result. So that's a slightly manual way of sorting the points by column instead of by row. So at this point, our example is sorted with column first, and then we do exactly the same thing, but with the variables all renamed to column instead. Pop off all the points. We're checking that the column index has changed instead of the row, and we're saving the row index instead of the column. And that's all we need to do from left to right. Although, to be more accurate, we're actually scanning from right to left and from bottom to top because of the order of sorting, but that doesn't change the result. Again, we do 2 last calls to extra fences once this while loop is completed, and then we return the result. And that's it. That's the fences around the function. Running cargo test on this gives us the right results for test 1, 2, and 3 based on the puzzle text. And running cargo run on this gives us the final answer. And that's it. That's all of the code. So I will be back tomorrow to take a look at day 13, which will be video 15. I'm really satisfied that this algorithm worked, and I'm a little annoyed that I forgot to record the screen, but that's okay. I think I've given a full description of what happened, although you missed out on all the pain of it not working immediately and me figuring out why. So thank you for watching. I'll see you in tomorrow's video.